So up next we have exercise 5.4. It's a simulation for the Apex Corporation that produces widgets. I'm going to make all these changes to the original example file, and then it wants the simulation to be for 24 hours. I'll do that under the run control, and then we're going to look at these four factors here. We're going to look at utilization for an inspector, the average time, load takes, each machine takes to assemble a widget. A lot of average times here. So yeah, let's dive right into that. So as I mentioned, I used example 5.1 in terms of like the names and stuff. I just changed around the times. So the box of widgets components arrive with a mean of 5 minutes. As you can see, I've changed that here. It's exponential, started by waiting for E. Down here you have the process time, where the assembly machine processes a component. It's got a mean of 12 minutes and a standard deviation of 2 minutes. And then down here we have the inspector, who works uniformly between 40 to 60, which is denoted by 50, which is the mean of those two numbers, with a 10-minute difference, plus or minus 10, which would be 40 or 60. And it says to print a message every time the inspector takes a break, and when he gets back, the inspector's break is 5 minutes, and this is supposed to be simulated for 24 hours. So what I did was I just did this command, these two lines, 24 times. So now we're going to simulate for 24 hours and take a look at the average time the load spend and the average time the machine spend assembling the widgets. So I click on run control. I'm going to change from 100 days of the original example to 24 hours. And then we're going to run the model. Ran the model and open the queues report. So we're looking at average time the widgets spend waiting for the assembly machine, average wait time, the average amount of widgets the inspector completes in a 24-hour period, the average number of components, and the utilization of the inspector. So we'll start with the utilization of the inspector. Right here it's 0.976. You have your average wait times of the widgets waiting to be assembled, and then the machine assembling them. Then you have the average number of components, which is in this average column here. So this concludes exercise 5.4. We're going to now move on to exercise 5.5. Here we have exercise 5.5. Similar to the last exercise, I'm going to use the example 5.1 model and just change around the numbers to fit this exercise. And so we're simulating this one for 28 days. We're looking at the average and maximum number of jobs waiting to be drilled. And then we're going to look to change numbers around to 3 hours to see what impact it has on the statistics. Okay, so we're going to run through this code real fast. First of all, job they're created every 10 minutes. That is right here, this line. We then have jobs processing times. We got a normal distribution, mean of 7.5 minutes, and a standard deviation of 20 seconds, which is equivalent to 0.33 minutes. Moving on, you have a drill breakdown time. It is an exponential distribution of 120 minutes, and the repair time is 15 minutes, also an exponential distribution. Next, we have the inspection, which is every hour, exponentially distributed at 60. Add minutes to the end of that. And the inspection time takes a mean of 2 minutes, exponential distribution there. Lastly, we have the time it takes until cleaning is required, which is a normal distribution of 120 minutes with a standard deviation of 10 minutes. And then cleanings take about 5 minutes to complete. So we are going to take that code and we are going to run it for 28 days. Go over to run control, edit, 28 days. And we are going to run this model and look at the statistics for the jobs waiting to be drilled. And then we're going to go back into the source file and change the MTBF time from 2 hours to 3 hours and see what differences occur. Ran the model for 28 days, as you can see here, and when you look at the number of jobs waiting to be drilled, you have your processes here. There were 10 total drillings with an average of 8.99. You go over to the queues. How many were waiting to be drilled? You had an average of 5.99 and a total of 8 with a maximum of 6. So it actually exceeded the maximum. The second deliverable was to change the MTBF time from 2 hours to 3. So we're going to change 120 to 180. We're going to run the model and we're going to look to see what changes in statistics. I ran the model and it looks like the number of jobs waiting to be drilled stayed the same both in the queues and process. So changing the MTBF time from 2 to 3 hours did not in fact impact the statistics when you're talking about the average and maximum number of jobs waiting to be drilled. Exercise 5.6 wants us to create a new model, and we're going to run this model for 1,000 days. We change around a couple of the distribution mean times, and we're going to look at MTBF time and MTTR times. So the previous example we had 2 hours and 15 minutes. This one, the first example, is 2 hours and 12 minutes. So we're going to change around a bunch of these times, and we're going to look at the average loads and the maximum loads, similar to how we did in the last example. Now the job process time is exponentially 8 minutes. So we're going to change that around. And then the MTBF time for the first one is 120, while the MTTR time is 12 minutes. So recall that we are changing the runtime now from 28 days to 1,000 days. And now I'm just going to run through each of the scenarios, different times, and show you the results for each one. So as you'll notice before, I had my capacity set to 6, and this problem calls for it to be an infinite capacity. So you'll see that the average is 71,996, and the maximum is 143,996. So that skyrocketed, obviously, when you raise your capacity to infinite, whereas before it was at 6, and the obvious average and maximum were both at 6. Now since it's at infinite, the average and max numbers jumped a lot. So now we're going to look at, that was 2 hours and 12 minutes. We're now going to look at 1 hour and 6 minutes. So here is an hour and 6 minutes. If your average is 71,996 and your maximum is 143,997, we're now going to do 30 minutes of MTBF and an MTTR of 3 minutes. So this is the result table for 30 minutes of MTBF and 3 minutes of MTTR. This is also the same exact table for 15 and 1.5, as well as 7.5 and 0.75. So after a while, it's all changed and kind of converged to the same average, where it's 71,996.43, and the same maximum where it's 143,997. Sure if it's the actual logic file itself that needs to be modified, or it's just meant to be the same maximum and average for each one. But this is the results, and this concludes exercise 5.6. This also concludes lab 5. I hope that you all learned something from today's lab and exercises, and I will see you all next time. Thank you.